So we will discuss now types of friction. So what are the different types of friction? So the types are divided into three parts. Okay, three types. There are three types which we study. So one is called static friction. Then we have sliding friction. Then we have rolling friction. So what is static friction? So when one object is trying to move against other object, suppose you have one object kept on ground and you are trying to push this object. And if that object does not move, it is only trying to move. In that case, the friction force which develops on the object is called static friction. So how can we define it? When there is no relative motion, only it is trying to move, means only it is intended to move, it is not actually moving, then the friction force appearing is called static friction. So no actual movement of body is observed in static friction. Okay, so suppose you have some object kept on ground, you are trying to push it, so the friction force will develop in the backward direction. So that friction is static friction. Okay, the force of static friction equal to applied force. So what does it mean? Suppose you have some box kept on a surface, you are trying to push it. Suppose you push it by 10 Newton and the box is not moving. So the friction force is also 10 Newton. The friction force has same value as 10 Newton because the box is not moving. The net force must be balanced. It is a self-adjusting force. The static friction is a self-adjusting force. And whatever force you are applying, the same force is applied by static friction to oppose that applied force. So these two are equal in magnitude. You can see the force of static friction is equal to applied force. Okay, next we will discuss this static friction in detail. So the friction force acts between two bodies when they are not sliding with respect to each other. When they are not sliding over each other. Example, see this one, you can see this man is pushing the almirah. Okay, but if he applies the small force, the almirah is not going to move. So whatever force is applied, the same developing backward direction. These two forces are equal in magnitude. Okay, so this is the static friction because object is not moving, but the friction is developing here. So that's why we were saying that the static friction was equal to applied forces. It is a self-adjusting force and it is represented as Fs. F for friction, S for static, Fs. Okay. Now we can study the static friction. See, if we have an object here and a string is tied here and we have a pan here. See, if weight in the pan increases, as we increase the weight in the pan, the tension will increase, and as tension increases, the block will try to move, but the friction will keep this object at rest. So the friction will also increase along with the applied tension, and tension increases along with the weight in pan. So as we increase the weight in the pan, the friction also increases. So static friction is what? Self-adjusting force. So as you increase the external forces, the friction is also increasing. The static friction is also increasing. Okay, now we have the maximum value of static friction. Suppose in that pan, which I gave you the example, if you keep increasing the weight here, after some time, after having some large weight, this object starts sliding. So in that case, whatever maximum friction is acting, that is called limiting friction. Okay, so maximum value of static friction is called limiting friction. So maximum value of static friction is called limiting friction. Okay, so this is the maximum value of static friction. Next we have dynamic or kinetic friction. So this friction appears when the two objects are actually moving with respect to each other. When two objects are having some relative motion with respect to each other, in that case we call it kinetic friction or dynamic friction. Okay, so at a particular value of weight in the pan, the applied force overcomes the limiting friction force and body is set into motion. At this condition, the body encounters another friction is called kinetic friction. Okay, so if that pan which I gave the example, if that pan starts sliding, the pan which I showed you 2 slides back, if the pan starts sliding, the friction acts on that pan in opposite direction of motion. So that friction is called kinetic friction. Okay, while object is moving. Okay, so you could see that this person, when he was moving, the friction between his shoes and the ice, because they were sliding, the friction will be called sliding friction in this case. Okay, so difference between these two, static and kinetic friction. Okay, so we will see with the help of graph. Okay, you can see this is the friction force and this is applied force. As we apply the force, as we increase the force, the static friction will also increase. The static friction is always equal with applied force. So these two are equal. Okay, and this angle will be 45 in that case. Why 45? Because these two quantities are same. So they will increase like this. They have same value. If it is 1 Newton here, here it will be 1 Newton. If you have applied force 1 Newton, then the friction force will also be 1 Newton. Okay. So these two will keep on increasing like that. But if the force reaches to maximum value, if this applied force reaches to maximum value, the object starts sliding. At this point, the object starts sliding. And once this starts sliding, we have kinetic friction here. And kinetic friction has constant value, you can see. But the kinetic friction is slightly less than the maximum value of static friction. The FL, which is written here, this is the maximum value of static friction. This is called limiting value, limiting friction. This is limiting friction or limiting value of static friction. Okay. So the kinetic friction is slightly less than, not very much less, but slightly less than limiting friction. And in many of the cases, we will see we take these two nearly same. The kinetic friction and maximum value of static friction is nearly same. But the static friction is not this one, but it is the whole range. Static friction can have any value between these two, but kinetic has constant value. This is the main difference. Okay. So when the applied force increases, the frictional force increases and reaches the maximum value, which is represented by a straight line in the graph. Okay. In this case, the applied force is equal to magnitude of FL in the opposite direction. FL means the static friction. Hence, the resultant force on the block is 0. We should write Fs, the static friction, not FL. FL is used for limiting value, the maximum value. Okay. So this we should write it as Fs. When applied force crosses W1, the body starts sliding. But the force required to keep the body in motion with uniform velocity is little less than FL. So in the graph you show the kinetic friction was slightly less than limiting value. So that is written here. The friction at this moment condition is called kinetic friction. This kinetic friction is slightly less than the maximum static friction. Now, if you compare these two, static friction, it is equal to applied force in magnitude. Kinetic friction, it is equal to applied force in magnitude only when sliding with constant velocity. Okay, if object is moving with constant velocity, only then it is equal. Otherwise, the kinetic friction does not adjust its value. It is having a constant value actually. Kinetic friction has a fixed value. It does not adjust its value similar to static friction. It is opposite to the applied force in direction. It is always opposite to the direction of velocity of sliding. The kinetic friction is opposite to the relative, opposite to the direction of relative velocity. We should write relative velocity of sliding. Okay. Sliding friction or kinetic friction is less than maximum static friction. Now we will discuss rolling friction. So what is rolling friction? When an object rolls The friction offered by ground is called, or friction offered by the surface is called rolling friction. So rolling friction is much less than the other these two frictions. The force of frictions comes into play when a body rolls over the surface of another body. So it is always easier to roll than to slide a body over another. So you can see that's why we have wheels on the different objects which needs to be moved from one place to other place. So what this wheel does, this wheel reduces the friction because the rolling friction is much less than the kinetic as well as static friction. The rolling friction is much smaller. See, when you are going for shopping, you have this cart, this kind of cart, and the cart is having a small wheels here. So the wheels are rolling. The train, bus, all the vehicles, they have the wheels. So these wheels are for decreasing the friction. The fan rotates. So the fan, inside the fan, you have the axle and actually one object. There are objects are there which are rotating on each other inside the fan. So these are the examples of the rolling friction between them. Cycle, you have the circular tires to reduce the friction. Okay, and this we have already discussed that why ball bearings are used between the two moving parts of the machines, because the rolling friction is much less than the sliding friction. So if these two, the inner wheel and outer wheel, if they will remain directly in contact, there will be a large friction. There will be a large sliding friction between them. But if you put some spheres here, then the friction will reduce because of the rolling friction is very much small than sliding frictions. Okay. Sliders are replaced in most machines by rollers using these ball bearings. When a spherical body rolls on horizontal surface, then the speed of body goes on decreasing and finally stops. So this is due to friction. The opposing force acts between surface of a spherical body and the horizontal surface is named as rolling friction. Okay, so this is the rolling friction. You can see the object is rolled and these are the small objects are there. So if you push it, some friction is offered. But in most of the questions, we neglect the rolling friction because rolling friction is very small. That's why we neglect in many of the questions. This rolling friction is significantly less than kinetic friction and which is less than the static friction. So you can write it like this. This is actually much less. So we should put a double sign here. Rolling friction is very much small. Okay. We should put a double sign here. Okay. Laws of friction. So what are the